ladies and gentlemen, so today we're going to start taking a look at the idea of unit rates, but now one of the numbers in our unit rate is going to be a fraction. And that's going to have a special name, which we'll get to at the end. But other than that, it really is the same type of thing, right? To find unit rates, we still have to divide. It's just that now we'll be dividing with fractions. You can still use the ABC key on your calculators to help us enter fractions. So this can be all done with fractions. But let's just kind of get into it here. So who is faster? And first of all, there were, it's supposed to be some decimal points in here. So we'll put those in. It says, during their last workout, Izzy ran, and that's supposed to be 2.14 miles in 15 minutes. I'm not sure that anybody could run 214 miles in 15 minutes. That's a little fast. And her friend Julia ran 3.34 miles in 25 minutes. Each girl thought she was the faster runner. Based on her last run, which girl is correct? So I'm going to find, it says use any approach, but I'm going to find their unit rates. So if I'm comparing for Izzy, she did 2.14 miles in 15 minutes. So you don't have to turn it into miles per hour, but that is an option. But that means she is doing 0.14, and it does keep going, but miles per minute. All right, so if I then do the same thing for Julia, she has 3.34 divided by 25 minutes. So we'll see if what we get for her rate. Her rate is 0.13 miles per minute. And it does, again, it keeps going, but so based on this, the person who's running faster is going to be the person who has the higher, the faster speed. So in this case, Izzy is faster. All right, so that was an example using some decimals. Now we're going to get into some fractions. So a turtle walks 7/8 of a mile in 50 minutes. What is the unit rate when the turtle's speed is expressed in, so this time now they want it in miles per hour? Well, we can do a couple of things. So down here is where they did it. So to do this problem, Meredith wrote the following complex fraction. So a complex fraction, and I'd like you to write this in, is a fraction that has the numerator or denominator, or both, as a fraction. So it's really a fraction within a fraction. And that's written out in the lesson summary as well. So I want to know, well, where in the world, explain how this fraction 5/6 was obtained. We know the 7/8, right? 7/8, that was how many miles? So we're trying to figure out where in the world did this 5/6 come from? Well, what they did is they took 50 minutes, but we have to turn that into hours. We know that there are 60 minutes in an hour. So if I take and reduce that, that's how I got my 5/6. So 5/6 is the part of the hour, an hour that the turtle or turtle that the turtle walked. All right, now they don't even ask us to figure that out. They just wanted to know, where did the numbers come from? So this is an example of a complex fraction, and in this case, both the numerator and the denominator are fractions. That's all that means. All right, let's see here. Exercises. Let's try some of these. For Anthony's birthday, his mother is making cupcakes for his 12 friends. The recipe calls for 3 1/3 cups of flour. This recipe makes 2½ dozen cupcakes. Anthony's mother has only 1 cup of flour. Is there enough flour for each of his friends to get a cupcake? So I first have to figure out, well, what's the unit rate? So how many dozen do I make for 1 cup of flour? So complex fraction. Again, I can use my ABC button. I could turn them into decimals if I wanted to. But I have 2½ divided by 3 1/3, which means you make 3/4 of a dozen per 1 cup of flour. All right, well, I need to know how many cupcakes are in 3/4 of a dozen. Well, I know that 12 cupcakes is 1 dozen, right? They need 1 dozen. So does she have enough? Not enough flour. Because she can only make 3/4 of a dozen. All right, let's try another one. So here's a chart, and we're talking about the number of quarts of red paint compared to the number of quarts of blue paint that is needed. And we want to know what is the unit rate for the values of the amount of blue paint to the amount of red paint. So we have to go through and divide those, do our unit rates. All right, I was having some calculator issues, so I paused it and tried to figure this out. So if I went through and did all of my division, I get the same unit rate, which is 1 2/3. So what is the unit rate of the values? So it's 1 2/3 quarts of blue to 1 of red. That's my unit rate, 1 2/3 of blue to 1 of red. You could turn that into a mixed number if you wanted to, but it's not necessarily needed. Or into an improper, sorry. Is the amount of blue paint proportional to the amount of red paint? Yes. Describe in words what the unit rate means in the context of this problem. I actually wrote that up here. But yes, I'm going to finish up here, same unit rate. So the only thing that's different today is that now we have some fractions. That's the only thing that's different. We still have to be able to divide to find the unit rate. Same unit rate means proportional relationship. So down here is where I told you we had the definition, so I'd like you to put a box around this. So it tells us then a number written in fraction form whose numerator or denominator is itself a fraction is called a complex fraction. Okay, that's what that's telling me. And then they go through and do an example for you. We, of course, can do them on our calculators as well. So any questions? Going into class? Otherwise, have a good night, guys.